run cabal run. So cabal run is actually going to fail now that I think about it, because I need to create this app folder and give it a main.
Just saying, it wouldn't make sense for the purpose of this demo, but there is like if you guys are starting a project, you can just do like cabal init. There's
Yeah,
also like cabal. I think this is now default, but you can do
yeah,
cabal init dash dash interactive, and it will like walk you through like you know do you want to add this and like there's even an option too to add like a ton of comments in the cabal file, like explaining like what everything is. Um,
yep.
so yeah.
So I just added that file there now, and we're going to have it run our main. It says hello Haskell. Fantastic. Okay. So now let's actually define our the domain model. So with anything, we're always starting at the domain layer, meaning the actual types that our code is going to use. We like to like something called domain-driven design is really popular in functional programming. And we can go into more of what that is, but it's really about just like what Galen was showing in the last lesson about like breaking your types down into the smallest possible pieces. That's kind of all that domain-driven design really is. It's just like modeling the real world in your code, doing that first, and then having everything else kind of build onto that. So first, I'll start with a shop. So I'm going to copy these all in. And just for sake of time, if there's any like of these that if there's anything I'm doing that doesn't make sense, feel free. But I'm just going to be copying in all the imports so that I'm not iterating through the compiler, having it tell me what I'm missing.
Effectively, all you're importing there is just the ability to do JSON manipulation.
Yeah, yeah. Okay, and so I guess first I'll model the shop.
And then type classes, I believe, is your own module.
Yep, exactly.
And shop error is a another great example of like what Kyle was talking about with domain-driven design, because it's like you know, Kyle, you'll probably get into this already, but like what can go wrong, and just like you're just thinking about what can go wrong with this logic, and then creating an error type so that you can it's much
Yeah,
easier to have this than just a string, which can be anything.
yeah. These can be pattern matched on. Um, there's a bunch of benefits of doing it like this. This is called a sum type or a discriminated union in other languages. It's basically just saying shop error can be shop number wrong length, or it can be shop number not numeric with a text, or it can be location code wrong length, or right. So it's this type can be any of these. And so what we're doing is we're just creating a object for shop, giving it a shop number, a shop location, and a shop name. Now you'll notice I'm not doing like shop number string or shop location code string. We can do this, but then we don't really have any way of knowing whether this string is valid or not. And so what we like to do, this is again going into domain-driven design. Domain-driven design encourages us to break it down to the smallest level, right? So a shop number does have rules. Like we have rules on our shop number. And so first thing I'll do is create the type for shop number. And I'll put it down here. Right, so we've got a new type shop number, which is a text. And this basically just allows us to work with it as a JSON type. And generic allows us to pass it. This is required for persistent. But again, all of like the compiler is going to tell us about all of these things. Like if you forget this, the compiler will tell you. So it looks like I might just be magically adding derivations here, but no, the compiler will tell us. and I can show some of that, but I just want to get this on the way here. So then we've got our data location type, similar to the shop error. I'm just modeling all of the locations that it can be. So these are all the provinces in Canada. It's a Canadian application. And then we're going to model the shop name, which is again just a text. So we've got our shop number, location code, and shop name. And then what we're going to do is we're going to use a concept called smart constructors. So basically, like any of these types, you could create them just by going like this, shop name. You could say that the shop name is dog, for example, right? This is okay, but like, what if we want to validate shop name? Then we have to write a separate function that makes sure that dog is actually a valid shop name. And so what we like to do is use this concept of smart constructors, which basically all it means is that we're adding some layer of validation before we actually create the type. And so the smart constructor is actually for shop number. So smart constructors start with MK before it. That's just like a language idiom. And what we're going to do is we're going to take a text and we're going to return either a shop error, that shop error that we created before, or a shop number. Okay. And so for make shop number, we just take in that text parameter here as num. And we're going to use, this is called a guard. So if you don't see an equal sign here and you just see it go right into a pipe, this is what's called guard syntax, G-U-A-R-D. And it basically allows us to one by one specify the types of, or sorry, one by one specify like different rules that we want to apply and then what we should do. So you're actually like using num here. So what we can do is we can say, okay, is the length, using t length, is the length of the number not equal to 4? If it is, then it's shop number wrong length. So this is the shop number wrong length error from above, right here. Otherwise, we can check if this, so LM just allows us to like check if an element, this is basically like the Boolean is equals. So we're saying if this, but it's for more than Booleans. It's basically like just checking if this is equal. So we're F mapping is number over each character. So F map, this maybe is a bit too much for this lesson, but this is functor map. So it's like a string is a list of characters. And so with the list of characters, the character would be a functor of the number. And so you can map over that, basically just discard the list or discard the fact that it's a string or that it's, count the fact that it's a list and just operate directly on the number itself.
It's kind of like map dot or like for each in JavaScript.
Yes. Yeah. Yeah.
Right.
Although you can use fmap for more than just enumerables, right?
Right.
So like if we were like in this case, this is pretty much doing the same thing that for each would do, except it's well, for each is relatively safe, but yeah, like fmap can be used for like everything, and I'll show
Yeah.
you, or anything that's a functor, which we can get into later.
Yeah.
Um,
And I will stress that point that it is safe. Like it's funny because like when you start getting into those kind of functions, like you know, list.find or like in JavaScript, like list.find, list.for each or whatever. It's very. I find that's like almost the easiest way to like have a like a runtime error in
mhm.
JavaScript because it just doesn't model it very well. Like it kind of like you know.
It still allows you to do indexing, so you can
Right.
still get an index out of bounds error, whereas this doesn't. There's no index. It's just for each thing that's in this list, it will unpack it. So this is just unpacking this num as text, checking if it's a number, and then returning a bool. And so LM will say okay, if any of these like this is going to return me now, and instead of having a list of characters, it's going to return me a list of booleans. And so lm will just run over that list of booleans, check if any of them are false. If that's true, then we're going to return our shop number, not numeric. So this is just saying, hey, I found something in the shop number that wasn't a number. And then otherwise, if I forget this otherwise case, and I might actually, in case of time, like I want to get this going. So if you were to, like, you'll have time to experiment with this code after. If you were to remove this, it would tell you that it's required, right? And so you always have to handle, like in Haskell, you always have to handle the true and the false. You always have to handle the if and the else, right? A lot of languages allow you to leave out the else. Haskell does not allow you to leave out the else. And that's very important. And then you might be saying, oh, well, you're just going to have else statements all over the place. That's why we have constructs like either, and all these different monad, like that's where monads come in and basically allow us to just make it so that like we don't have to write that everywhere. All of those side effects are just going to be passed down to their lower context. So I will move forward and define the other smart constructors. This one's for location code. It's just checking if the location code is 2 numbers long, and if it exists within maybe from text. Yeah, so from text LC, we'll return it. I'll have to implement that after. But this is using a maybe, so it could still be false, right? The invalid location code will tell us that it doesn't belong to this list here.
Kyle, just for a quick heads up, just a time check that it's 11.
Yep.
Just to keep you on track for timing and to allow for some questions after if there are.
Yep. It's good. I should take me. I'm just gonna power through this. There were a little bit of issues at the start there, so. So then we've got another one, make shop name, does the exact same kind of thing, and then make shop. So this we won't explain too much in terms of time, but this is basically just applying all of these different functors to the shop type. So we're creating our shop here.
And I'll explain this quickly because I feel like this can be complicated to explain, but we do want to explain quickly. If you look at, could you pull up? So notice that like there's like 3 like pieces here. And if we go back to shop, we'll notice that there's also 3 pieces.
Yeah.
So yeah, this is basically like, so ultimately like why we need this like sort of syntax with the with, or it's not actually syntax, these are like functions to help us out here, but the dollar sign and the asterisk things are because make shop number, make location code, and make shop name are all returning an either, either either a shop error or the thing. And so we want to then combine from all of those possible failures. So
Yeah.
what this will do is, like, let's say this fails at make shop number, then the shop error will be the same from same thing that was thrown by shop number. Um,
Yeah,
and
exactly. This is what we were talking about, where you don't have to handle all of these cases everywhere. We're just mapping over them. We don't care that we don't basically, when you learn more about this, it'll make more sense. But we're basically saying we don't care about the either in this case. We just want to use the we're going to return either a shop error or a shop. And so shop is expecting just this shop. So if all of these succeed, or sorry, yeah, it's just referring the shop name location code. If all of these succeed, then shop will be created. If any of these fail, it'll return whichever shop error came from either of these, and it'll return that as the error. So it's really, really nifty.
And too, so like just a note on these like sessions, like um because this might be the case here, if you're like feeling like any bit like overwhelmed by um I don't know, maybe the syntax here, like this is where like the lessons really do come in handy. The the way that you should use the individual lessons and then this these sort of video lessons. These video lessons should be like exposure to like how do you actually do Haskell or whatever. What's a concrete example you can kind of look back on and say like if I want to make a database, how do I do that in Haskell? Um, whereas the individual lessons will teach you stuff like how does either actually work. Like if you want to get into that and how does these functions here actually work. And so if you really are detail oriented and want to know absolutely everything that's going on here, then like those lessons will really help you out.
Yep.
So and we're
Yeah,
here to
exactly.
help. So if there's any questions, like even like right now, like fair. Like we really encourage them to be asked. I think it also makes the session more fun when there's more questions.
Yep.
You know.
So I'm going to just do this, copy this automatically. For product, we're doing exactly the same thing here. It's just we're modeling a product instead of a shop. So I'm not gonna go through each line and explain this, although I'll just show the product type. We've got a serial number and a product name. So the next thing, I'm just gonna copy this type class in here. This is not super necessary for you to understand yet, but this just allows us to get the text out of any element.
Sorry, I don't know if this is on purpose. I'm not seeing any typing, or I'm not sure if it's on a different screen. Maybe
What do you mean?
like I just see like make shop still. I saw you were typing some classes.
Do you see type classes right now?
I just see like make
I see
location
type.
code. Wait, what? Oh,
Yeah, I think your screen's frozen.
okay.
Maybe
There might
I'll
be,
try to. Yeah.
because I'm seeing type classes dot, like your type classes file.
Never mind.
Yeah.
Just ignore me then.
Well, I'll just because someone else might have that issue too. Let me
That's
just
fair.
reshare my screen.
Anybody else? Kelvin, Legita, Sarah? Can you guys see, or one second.
There should be if it's fixed for Galen.
Yeah, I can see his type classes.
You can see type
Go.
classes?
Yeah,
Okay.
I can.
Okay, good. All right.
Perfect.
So that is just a detail. We won't focus on that right now.
I'm gonna drop off and come back on. That's what I'll do. I'm not sure
Oh,
what's
okay.
happening
No,
to
it's
me.
not working still.
Yeah,
Sure, sounds good.
it's whatever. I'll figure it out.
Yeah, it's a local issue. Okay.
Recording
These
is
will probably
on.
get removed from Haskell at some point. Basically, what this is like it allows people to add features onto the language, and so the team behind the Haskell compiler has already said like many of these are just going to be added into the next version of Haskell, and so they basically just allow us to write code in certain ways. Don't focus on them too much. We'll usually be providing like you can put all of these into a Cabal file and then you're fine. You don't need to worry about it. I just put them here just to show that they exist. So to create our database, it's actually very easy. It's probably one of the easiest. So there, database is created. And so basically one of the things that Haskell's really good at is creating like domain specific languages. So like languages within the language. This can be slightly confusing if you don't know that you're working with one, but when you are working with it, it's very, very powerful. So this share type comes from persistent. And basically what we're doing is we're just creating a persistent database with the default SQL settings. And then we're running migration and we're just migrating everything in our database. We won't get into database migration today, although you will see what it does. And then persist lowercase, this is literally just telling persistent to turn all of these types into lowercase, or like all of these tables into like lowercase styling. So what we're doing here is we're actually we're doing two things. Not only are we defining the table, but we're also creating a type that perfectly maps to that table. So product registry has, a serial number and a product name, and then this U before the product registry here, this means that this is a unique key. So you might have heard like primary keys, foreign keys, unique keys. This is creating a unique key called product registry, and it's attaching it to serial number. Okay. Similarly, we're creating a shop registry. This has a shop number, shop location code, and shop name, and then a uniqueness constraint on shop registry, which is unique on both shop number and shop location code. So like this literally creates the database for us. There's nothing else really that we need. I mean, we need to execute this, but this does everything, which is very, very cool.
I'll add some points of verbosity here. So I
Yeah.
believe that you must be using template Haskell.
Template Haskell, yeah.
Yeah. So this example like is not super familiar to me, by the way, if you're watching. But yeah, so template Haskell is basically just a meta programming of Haskell. Like you can like how I'm able to kind of figure this out is that like Kyle, you're saying that it creates the data type for you. So basically, what this system is saying like work with our domain specific language. There's probably some documentation you've read somewhere on how to do that, and
Yep.
then it's going to create these data types for you. And I think you even like like how we had shop or shop code, I think was a data type. How you saw that in like in functions, you can do the exact same thing. You can write functions which use these types.
Yeah, and so that's what we're actually going to do right now. I'll show you. So I've just created a run DB function. Again, this is just in their documentation. There's pretty much one way to do it. And we're just basically saying, okay, with this string connection, give me the back end and then run reader T on this. So this is, I won't go into the reader monad right now, but basically this is just running this database. And then there's a migrate DB function as well. And so this is like, we're working with a library. Like you could go into persistent and like understand exactly what it's doing. But in this case, like we don't need to. We just need to set up our database and we need to run it.
And actually, I can see too. Just I think the quickest way of explaining what that is doing, the run DB, how it might look complicated because it's using like a higher order function and reader T or whatever. But I can say that what that's doing is it's really just passing a config from Postgres to your functions. So like anywhere that you would need to use like sort of Postgres config, you were able to do that effectively.
Yep. Yeah, and the action that we're passing to RunDB is the migration action.
Makes sense. So it probably has like some config about where the database is located, like your connection string, and then runs the.
Yep.
Yeah.
Yeah, exactly. And so I've just created two functions here. These functions take in a product and then return an SQL persist T, which is just a monad transformer for SQL persist. So this has everything that it needs inside of it to do persistent SQL queries. So it'll handle all the side effects that it needs. Maybe it stores onto some state, it interacts with the Postgres database, which is probably a custom monad that they've created for persistent. And then we're going to be returning a maybe insert error. So it'll either return us no error or an error.
You use a new term that I think we should elaborate on monad transformer. What does that mean? It sounds like complicated and like cool, maybe like
Yep.
transformers. But but
Yeah, you can go ahead, Galen. But just
so
keep it short.
yeah, totally. So a monad transformer, what like builds off this core idea of monads. And so I'll start with what a monad is. A monad, like when we talk about it in this sense, really just allows you to do some sort of effect. So either, for example, is a monad, and either has the effect. You know, which you saw how it works already. There's nothing more complicated or behind the scenes about it. Um, it just allows us to model failure. Um, so let's say we want to model failure, but we also want to have a monad that does SQL stuff. So we can stack the two on top of each other, um,
Yeah.
and yeah, and we don't
That'll
necessarily
make
think.
a lot more sense in the future, right?
Yeah,
It's a little bit confusing. Like, why would you want to stack them on top of each other? Basically, you want to be able to. We're specifying layers of an onion by doing this, right? It's like this thing should handle errors, but it should also communicate with the database. It should also store some state.
yeah,
And the reason why we're doing that, you might think of it kind of like inheritance, but inheritance doesn't do a lot of the same benefits. Like this actually binds the context and allows us to, again, use those same monad functions, those same applicative functions to sequence these operations together in a safe way. So it's like inheritance kind of, but a lot more powerful because it first of all, everything is like you can pattern match on everything. Everything is constrained to the same type. Whereas with interfaces, oftentimes they're scattered throughout the data, throughout your code base. They don't really like. There's no guarantee that an abstraction of an interface will also work with the other abstraction. Like if you have two abstractions of one interface, you don't have any guarantee that those two abstractions will be able to communicate with each other. Whereas in this case, it kind of handles a lot of that complexity for us. And so you could have the either effect be applied to, the state monad, for example.
Even to bring it back to like a JavaScript example, try catch is technically a monad. You guys are probably like you know you can get very complicated in the explanation of monads or
Hmm.
whatever. I actually like I had more experience for a while with Haskell than JavaScript, and the way I thought of monads is that all they do is allow you to ignore them. Like
Yeah, yeah.
either is like so the either monad like that term or whatever, either is what's doing stuff for you. The either data type allows you to model failure. Monad is just it's a class, and we haven't talked about type classes at all and how they work in Haskell. Um, but it's just basically an interface to say I don't care about either. If it like so, let's say we have like the simplest example is we have two eithers with an integer in them. So we did some validation that this integer is not zero. So we have either fail what the failure says it is zero, or a integer. And so now we want to add those two together. We can use monad rules to add the two together so that our inputs are an either error int and an either error int, and our output is an either error int. And all we've done is we've effectively just added 2 plus 4 or
Yeah.
whatever the heck the integers are.
Yeah, you can specify what the internal types, what logic should be applied to the internal types without focusing on the external. Is kind of a good way of thinking.
Yeah.
This is a container. It's like an onion, right? And we want to go directly into the third layer of the onion without ripping off the second and the third. Or technically, we're ripping them off, but then we're putting them back.
Yeah.
Okay, so with that, I've decided to just go ahead and write down the API code here because this is not the focus of this course, but I will just show you it because the code will be available and you might be wondering. So what we're doing here is just creating HTTP routes. This is using the servant package. And then we're just creating a server which runs these two functions, create product and create shop. And these are literally just calling our database functions. So we get a response, we pattern match on that response. In the case that it's a value, we show it. In the case that it's not, or sorry, just as an error. So in the case that it's an error, we show it. In the case that there's no error, we just say success. So that's very simple. The application starts it up. And then here is where we're actually doing we're actually starting this code. So I will just run this because I feel like we've talked enough about it. The one thing I just want to note is that you see here with this insert unique function, product registry, where we didn't create a product registry type anywhere, right? But we did right here. So this is actually creating the type that we can use in our code, which is very neat. So this here models the database. So now if I run Cabal run and cross my fingers, okay, there's some error, variable not in scope, variable not in scope. Okay, why is that? Oh, yeah, okay, my bad, I did not import them. So I'll just import these. Did I forget type class? Did I forget what? I might not have copied over all of the.
You probably.
No, I know what I need to do. Yeah, it's just. Oh, yeah, I didn't. That's why. I didn't copy over the language features. So like you see here, it'll actually just tell me, oh, you're doing something that requires a language feature. I think for product I did I? Yes, okay. Not gonna worry about these. They're just telling me that certain things are not used. And so if we look before, like if we remember, we have no tables, right? And so this, look at that. It actually just created a bunch of tables in our database and it started up a server on port 8081. So if we come into here, we refresh our tables, we now see we have our product registry and shop registry. So if I open these, data, all rows. You can see here that it has the types that we created. It creates its own ID. And then we've got our shop number, shop location code, and shop name. And so this, like, for example, in Postgres, this uses character varying. But if we were to use a different type of database, it would create whatever so it binds the database type to the actual type that you specify in the code, which is pretty powerful. If you've done any work with databases, you often have to specify this yourself, and sometimes there can be issues that come with that. And so, yeah, both of these are now tables in the database with the right fields. So what can we do with that? Well, now we can use the API here to actually interact with the database. So I've created these two routes, API product. This basically just means a slash. It does a little bit more than that, but it's a slash. So this is going to be API slash product slash create. It's going to take our product as a JSON object, and it's going to give us JSON text back. And so, like we said here, it just calls create product and create shop. So I'll show that while Galen's talking.
Yeah, well, I'm even just curious, like with seeing that for the first time, obviously there's it looks like there's like new syntax. There's actually not any like new syntax there. So
good point. Yeah.
Yeah, but I'm curious, like, can you kind of like get if you're familiar with APIs, like, can you read that at a high level and think like, oh, okay, like I kind of roughly get what this is doing, Maybe like you feel uncertain about
Important,
it,
yeah.
but you know, um, like because I mean, of course, I can. I'm familiar with this servant API library. But I'm curious. Like I think one of the cool things about Haskell is that it is so flexible that it allows the the library creator to model things in such an intuitive way. So like I can look at this, and I'm really curious about that answer. Like if you guys want to give an answer in the chat, if not, no worries, no pressure. But to like, can you read this and get an intuitive sense of what's happening here?
Yeah, and I want to that's a great question. Please do answer if you can. But the one thing that Galen said is actually really important. There's actually very little syntax in Haskell. A lot of people say there's a lot of syntax in Haskell because they see operators. They see these things, right? They see, oh, there's this colon. How am I ever going to remember all of these operators? Like like there's so many different operators that we're using. They're not operators, they're functions. And so each of the, like, I won't go into it right now, but like each of these can be, so you can write it in two ways. I could go API like this and then shop, or I could do this, right? And so this is just a function that gets applied to this and then this. And so this gets into what's called infixing. And so any function, like actually any function, like even this create product, if I have any function can be either prefix or infix, meaning it can go before and have all the arguments here, or it can go in between two arguments and take the first argument from the left. This we'll explain this more in the theory documentation, but just understand that like anytime you see these, they're not like specific language thing. Like this belongs to the servant package. It's a function that they created, and they just made an operator. They just made the operator infixable. So you're able to put it inside of two parameters as opposed to having to define it like this all the time. But it's exactly the same thing. It's just a function, and you can look it up and you can understand what that function does. So don't be like, don't worry like that you have to remember all of these operators. No, like they're just functions that you can search in Google.
And I'll add to like, so I think servant is one of the coolest packages in all of Haskell, in my
Yeah.
opinion.
Mhm.
You know, if like the complexity of like how the library is built, like the mind of the creator who made servant must be an absolute genius. And it's like it's really hard like when you like try to dig deep into it to like understand like how did he do this, because like you can really use a lot of powerful features in Haskell. But that said, you also don't need to know that at all. You can look at their servant documentation, and you could literally like learn about the two operators, the colon, yeah, the one that the one at the start of line 25, and then um, the other one, the like
That's not it.
the colon angle bracket and the colon angle bracket angle bracket bar. Let me just type in the chat. This one
Okay.
here. And this function. You can literally learn about these two functions, and you'd be just about good to go with Haskell. Or sorry, with servant.
Yep.
And you don't even have to like look at this Google documentation necessarily, because there's like a tutorial on like how to use it or whatever. The key point is like Haskell, like one of the sneaky um, points about Haskell is that like I guarantee you, and not even guarantee you, I know that this is true at this point, that Haskell has better libraries than any other language. Like dead stop.
It's the best for creating libraries. Like
Yes.
we can use it, but traditionally Haskell has been a library language. But now the runtimes are getting really, really strong. So it's like, why not use the libraries in the actual runtime itself as well?
Right.
So yeah, so that without like just time check, without getting too deep into it, this really just gets the point across that like they're just specifying this as an infix R4. So this means we'll get into infix, but basically just means it can be added in between two types.
The only last point I want to make is that like you have a library creator who's done something amazing, and then what they've done is they've exposed a very small domain driven design to you that all you need to do is understand that, and then you can build something that like is absolutely perfect. And even if like you along the way are struggling to do that, once you know the basics of Haskell, you can kind of like almost play compiler chess, and um, you know you'll end up with this beautiful API that works perfectly, kind of thing.
Yep, and the big difference between this and JavaScript libraries is you can trust the library developers. When you're using a JavaScript library, you cannot trust the developer. There's no like, what if they forget a catch? What if they forget an else statement? You know, this happens all the time, and you're always seeing packages get patched and everything like that. No, this will work exactly how you expect it because they're using Haskell as well. And so with that, I want to show how the application actually works, and then have some time for questions. There is a quick second part to this, but depending on time, we'll see. So what I'm going to do is this is Postman. This is just simulating a network request. And so I'm just going to make a request to this API/shop/create. It's going to expect a JSON object, which if you remember in here, we created an instance of to.json and from.json, and we specified this is how we want the to look. So we want it to be shop number, shop location code, shop name with lowercase or with camel case. And so there we go. And if I hit send, it says success. And then you can see down here that it actually, first it did a select to see if it was unique, and then it inserted. So we didn't tell it to select to check if it's unique and then insert. It just did that because we specified that we want it to be unique. So actually, no, it was this insert unique. So insert unique function is what handles that for us. And it's able to do that because of the unique type. And so if I check the database again, it was the shop. We can now see our shop here, right? I can try to add it again, and we will get that shop error here. ON, shop number 1200 has already been stored. So if I want to add another shop, let's add this one for Quebec City. Shop QC. We can add that as well. Similarly with a product, this is an example. So the second part of this example is actually attaching the thing, but we might not have time for that. Give me a second here. Okay, so we can now also create products with the serial number and a test product name. If I try to add a serial number with the same serial number, it's already been stored. If I try to add a serial number that is not 8 characters, the serial number you provided is not valid.
Recording has stopped.
Oh, Lauren dropped, I think.
Oh.
Temporarily, I think, maybe. That's okay.
Well,
You still
hear
have
me?
OBS. You still have OBS, right? Kayla?
Yeah,
Wait,
I still,
you
I
guys,
still have OBS. Yeah.
Okay, good. Sounds good.
I can hear you, Laura.
it just stopped the recording for me for some reason.
And so there we create another.
Okay. Well, that's all right. I have OBS.
Recording is on.
We can stitch them together.
Yeah, no problem.
And so there we go. We've got 2 products now with 2 different serial numbers. And so that's really like you can keep growing on this, get more complicated, right? We can have foreign key relationships between different tables, etc. But I think that's really all we need to show at the moment. And so we've got 30 minutes. If anyone has questions, we'd love to, or even just comments, what did you think about that? We'd love to hear them.
Okay, so 2 things, Kyle. There's 2 questions from Sarah in the chat itself, so maybe take a
Okay.
look at those.
Oh, yeah.
First one is, can we run PG admin for SQL through Haskell? If you can see that, and then maybe just take a look at those. And then in the meantime, while Kyle is taking a look at those guys, Sarah, great questions. I love that you're engaging. It's so nice to see you get involved. Kelvin and Olajita, of course, this is your time to ask questions, so please do. Like I said before, our groups won't be so small for long, so this is your time to pick their brains, even if it's not about today's content. Like if you're still just digesting what you learned today and it's about something else, now is the time. So please feel free and give us feedback on the content. Like, was it super confusing? There was nothing that you got. Let us know how you feel about that, because we're here to build for you guys. So Kyle, maybe you can get started with Sarah's questions, and then Kelvin and Olajita, if you have any questions, drop it below.
Sure. Yeah, I can. I'll answer Sarah's first question. So, can we run PG admin for SQL through Haskell? So this right here is PG admin. You can't run it through Haskell, but you can run it through Nix. Right now, I'm actually just running it on Linux because so Nix OS is fantastic because it lets you just like set it up automatically. But for me, all I did was I just downloaded it from the Snap store. So like Snap is like the app store for Linux. That's going too high. Where did I do it? Ignore these errors. Yeah, so like I just downloaded it from the Snap store and just ran it here. So like as long as PG admin is running on your like it's running on the same machine that the server is running, it'll have no problem connecting to the database. In order to do that, I just came into servers, registered a new server, gave it a name, and then like here is where you can add the credentials from this in database. So we have this connection string here. So I literally just added like host is localhost. The DB name will be DB serialization. That'll be once it gets in. User, I just put in my username here, right? And the password of very secure password of password123, right? And then that just allowed me to create this here, and then that lists the DB serialization database once I create it. So you can do everything inside of PG admin. You can even write your own queries in here. But yeah, we're also interacting with it from the database. And then how to apply Haskell to data analysis.
The last thing I was going to say too, by the way, for the first question is just like when we get to Obelisk, we could also. It's not really the same question, but like it is a lot easier to set up like database administration through Obelisk. Or like there's a lot less like manual setup that you have to do for that specific library, but it wouldn't make sense.
Yeah, there's framework. There are frameworks, right? But we didn't want to show you how it works before we just show you the magic.
Right.
For data analysis, yeah, do you want to take that one, Galen? Because I know you've done a lot of data analysis with Haskell.
Yeah. So we although we've very much slowed down on our efforts and kind of shifted direction with our data analysis, um, we have done a lot of like natural language processing. So as well as like even in a lot of my own projects, I've done there was a time where I did a lot of like Amazon projects. So automatically analyzing people's storefronts on Amazon, determining what products they should buy more of, etc. And so like the two, I guess, like workhorses of that is like A, getting data, and B, analyzing data. Um, I've actually created my own library for web scraping and Haskell to very precisely scrape data in a particular but dynamic way. And so like that's how I would use it for getting data. On the other hand, which is probably more aligned with your question, like data analysis, there's quite a few. I've kind of also just built my own as well, but that's more for fun. Like there's like Cassava is like a CSV library. There's like text.csv. And I find it a lot easier to model complex relationships because like otherwise, like if you're doing it in like Python, for example, you're just you're looking at it as like rows and columns, and that's kind of like the extent to your data types. Whereas there's probably a more complicated relationship in there that you can derive through certain checks. So maybe that'd be a great that'd be probably a great session to go through is data analysis in Haskell. I think that deserves its own session. Now I think about it. But yeah, lots of libraries to do like CSV analysis and that sort of thing.
I'm pretty sure there's even like TensorFlow packages and stuff like pretty much. Okay, like name a package
Oh,
in
Matplotlib